A partial solar eclipse in 2012. David Zalubowski, Associated Press. Tens of millions of Americans have an exceedingly rare opportunity this month. There's no way I'm going to miss it. How about you? On August 21st, a total solar eclipse will be visible in a band about 65 miles wide stretching from Oregon to South Carolina. This will be the first coast-to-coast totality in the United States in 99 years, though, most recently out of the 20th century's dozen American solar eclipses. Hawaii had a total eclipse in 1991 and the Pacific Northwest had one in 1979. Having seen 33 total eclipses in my life, I implore anyone who can to take advantage of this experience. My reason for traveling to see the total eclipse may be different from yours. For me, it's a rare opportunity to study the corona, a major part of the sun's atmosphere that can be seen only during the 2 minutes or so of a full eclipse that the moon blots out the solar surface, preventing sunlight from turning the sky blue. No spacecraft or Earth-based telescope can observe that part of the sun with the quality we get during an eclipse. But, assuming you're not an astronomer, why should you make the same pilgrimage? It is simply the most spectacular thing you can ever see. Words can't do justice to the primal feeling of eeriness and awe evoked by this celestial event, but here's what to expect during the first hour of partial eclipse, which you can observe safely only through specially certified filters available for $1 or $2 and free at many libraries. You wouldn't know that anything special was happening. But the last 15 minutes or so bring sharpening shadows, changes in the light, sometimes cooling winds and a darkening sky. Faint ripples on the ground, known as shadow bands, may cross the landscape. The most impressive part is the final minute as the sun transitions from 99% to total coverage. The sky abruptly gets about 10,000 times darker. Just before totality, at the rim of the sun, a crescent of sunlight becomes broken by mountains on the edge of the moon, the so-called Baily's beads. The last bead gleams so brightly around the moon's silhouette, as the sun's spiky corona becomes visible, that the eclipse looks like a diamond ring in the sky. At that point, your safety glasses become unusable, since they are too dark for totality. The corona is the same brightness as the full moon and is equally safe to look at with the naked eye. All around the moon, the glorious corona halo of the sun is visible, as are Jupiter and Venus and even a few stars elsewhere in the sky. The horizon glows red from the light outside the moon's shadow. But to see these dramatic glories, you must travel into the zone of totality, which traverses parts of 14 states. You should try to get there even if you have to drive many hours. If the sky is clear, you are guaranteed to find it worthwhile. If it's cloudy, the sky will simply get abruptly darker. If you're not in the zone of totality, as will be the case for most of the country, the eclipse will be intellectually interesting but not dramatic. If you look always through a solar filter, perhaps at 5 or 10 minute intervals, you will be able to see that a bite has been taken out of the sun. Because this eclipse is so accessible, scientists have planned dozens of expeditions. My students, colleagues and I, with support from the National Science Foundation and the National Geographic Society, are bringing some 2 tons of equipment to Oregon to capture as much data in our computers and cameras as possible in our 2 minutes of totality. We hope to learn more about how the sun shines. We want to know how the corona is heated to millions of degrees and how eruptions from the sun that impact Earth, now known as space weather, are generated. The safety of satellites in orbit, power lines on Earth and even passengers in airplanes, especially those on polar routes, may depend on our knowledge of solar eruptions. In the past, total eclipses have led not only to the discovery of a new element, helium, but also to the realization that the corona surrounds the sun and not the moon. That Einstein's general theory of relativity correctly predicts the displacement of stars near the sun, and that the outer part of the sun, and therefore of trillions of other stars, is somehow heated to millions of degrees. But the most important scientific outcome from this year's eclipse may be more fundamental, inspiring a 7 or 8-year-old girl or boy somewhere to enter a career of science, perhaps even leading to her fantastically wonderful discovery 20 or 30 years from now. Seeing the event on a TV or computer screen simply won't do. Our future scientists need to see it outside with their own eyes. It might just be the key to some hitherto unimaginable breakthrough benefiting all the people of the world.